Hey guys, so I'm going to show you a video today about pipeline processing, and we're going to get a little bit more in depth with it today. It's a hard problem. You've got thousands of events that are coming into the system, and they are going to get turned into streams, and then those streams have to get processed, and if something goes wrong along the way, it's really hard to find out what broke. So why are my events not going into the streams that I thought they were going to go into? Why are my streams not triggering and turning into are not getting processed into pipelines? There's a lot of places where things can break along the way, and looking at log files for that sort of stuff is actually quite difficult. So recently in the code I added a primitive debugger, but it puts hooks in throughout the Oahu processing pipeline to make life a little bit easier, so you can debug this stuff a little bit better. And it's flexible enough that we can really turn it into something cool down the road. But in order to get into the debugger, before I get into the debugger, I need to show you, in depth what happens with this. So this is a slide that I've shown in other presentations and in other screencasts, which basically just says that the way that processing works is that you get the stream of events that come in, and they get sent into some sort of a bucket called a stream. And this is a stream of related events, and this is about as much depth as I got into with it. But that a stream has a variety of different states. It can be collecting gathering up events. It can be in the ready state, which says that I've met all my criteria and I'm ready to do something with it. And then it goes into processing, where we're actually going to process the pipeline. And if that fails, it can go into one of two states. It can go into an error state, or it can go into a completed state. So, and this is all correct. I mean, this at a high level, that's really what happens. But now we want to dig into that a little bit deeper and actually find out, how does the collecting phase work, and how does the ready phase work? So how do we take these raw events and dump them into the appropriate stream? And then once they're in a stream, how do we determine that the stream is ready for processing? So let's go into a little more detail on that. So this is a variation of that same slide. So at the top here, what we have are these loose events that are coming into the system, and they're getting gathered up. And in our situation, they're being read from RabbitMQ or from some queuing system, and they're getting processed. And for us, we use Yagi to do that collecting. So we have a handler within Yagi that reads the events right from Rabbit and decides where they should go. And so this is in the collecting state. And what we're doing here is we're looking for traits on these events to determine which stream they should go into. And a trait, again, is a key value pair inside of an event. So an event is a big nested JSON data structure, and any key value pair within that is what we call a trait. And we use a notation kind of like a JSON filter query, where we can say, payload dot image type, for example, which means the dictionary inside the payload dictionary. And that way we can retrieve key value pairs out of this nested data structure. But to keep that simple, we just call that a trait. So that can mean some key value pair way down deep in the data structure. So we have our first set of information here, which is our trait match. And this is a thing that says, okay, an event came in, and if we have this trait, if we have a trait that we specify, then that's going to go into a stream somewhere. And that's really as simple as it is. And then based on the value of that trait, that determines which stream it goes into. So as these events are coming in, Yagi is going to grab them. We're going to look and see if it has a trait called request ID. And if it does, then we're going to look at the value of that, and we're going to create a stream. If the stream doesn't exist, we'll create a new stream. If the stream does exist, we'll tack this event onto the end of it. So let's say this event here comes in, we look at it, it does have a request ID trait, and the value of that request ID is REQ 7FFF AABB. Then we find the stream for that particular request ID value, and we add that event to it. Another event could come in right afterwards. It could have a request ID, which means we get a trait match, but the request ID is different. So now it's CCDD. And what would happen then is a new stream will get created, and this event this event here would go as the first event in that new stream. And like I say, we could have, for as many events as come in, we could have a unique stream for each of them. So we can get a lot of streams. And this is happening very, very quickly. So we need a better way of, when we're going through it, we want to find out, well, why did my event not go into that stream that I wanted? So that's where the debugger comes in. It's going to give us some hints as to what's going on and why are these events not going into streams that I had defined. The second part of the equation is to look at these streams as they come in, and we want to do a criteria match on it. And the criteria match says that some of the values in these events have matched up, or something in the stream has matched up and we're ready to do processing on it. And that's what we call a criteria match. And we have a different worker that does that. It's called one of the Oahu workers. Periodically looks at the database and it looks for streams that are in the collecting state, and then it compares the criteria match on them to see if they should trigger or not. So one expiry criteria for this, let's say for this stream that we've defined, that the distinguishing trait is request ID, but the criteria for it is an expiry criteria, which says that if there's no activity on the stream for an hour, then this stream is going to trigger. And we've shown this example in other screencasts. So these are the two important parts for determining stream processing. The very first step is that we have a trait match on the event. The second part of it is that we have a criteria match for triggering. And if those two things happen, then this stream will get sent off for processing. And in a later screencast, I'll talk about how pipeline processing works and how you can actually do some operations on these events. In the past, I've just shown you a simple print statement that said that it's ready for processing. But now we've extended that out and we can do some funky stuff with it. So let's get into some of those details. So again, remember, we've got two workers that are happening here. One is a Yagi worker. We could have many of these that are collecting streams or collecting events from a queue and dumping into the appropriate streams. And then we have another worker or collection of workers, because you can scale this out with multiple workers, looking for streams that are ready for processing, or ready to trigger anyway. So let's get into some of that. So the first thing I'm going to show you here, this is our set of trigger definitions for our pipeline. So this is in Sandbox, the Sandbox repo. If you install Sandbox and run it, you can get this exact same thing going in your dev environment. So in this situation here, I've got two streams defined. I've got a request ID stream, or trigger definition is what we call it, and it's named request ID. That's just a unique name to make it friendly, so we'll see this show up in debugging statements and things. And we have another one down here, which is end of day exists. And they both do different things. They're both relatively complicated for their own reasons. But we're having some problems with the end of day exists ones, and we want to get some details on it. So I've turned debugging on for both of these streams, and you'll see some. So the nice thing about the debugger is that you can turn it on a per stream basis. So I can, rather than have just a big ream of log messages coming out, if I know my other streams are working okay, I can turn debugging off and I won't get any messages out of it. But if I have one that I'm working on and is giving me trouble, I can turn debugging on for it, and I can fine-tune how much output I get from it as well. So we've given it a name, and we had to define our match criteria. So remember, the match criteria are the traits that we're interested in. That's the buckets that it's going to go in. And in this case, it's _context _request ID, which out of OpenStack is where a request ID is hiding in the payload. And then we have our trigger criteria, our firing criteria, basically, which is a class called inactive, which is a predefined criteria, which says that if I've had no activity in 60 seconds, then I want to trigger this thing. And when it does trigger, this is the callback that's going to get called to do the pipeline processing for us. So that's our trilogy of things that we need for defining a stream. What's it going to match on? What's it going to trigger on? And what are we going to do once we've triggered? And again, in this situation, we've turned on debugging. This one down here is a little more complicated. This is the one that specifies the end of day exists records. And in this situation, what we're looking for is payload/instance ID. So again, a nested structure. So in the payload dictionary, there's a thing called instance ID. That's going to be one matching criteria for our buckets. And the other thing is this audit bucket thing, which is a date that the event came in on. So we have two matching criteria here. So if we have a matching instance ID and date, then that's going to create a stream for it. But let's say we have the same instance ID on a different date, that'll be two different streams. So in this case, we're being more fine-grained on our stream definitions. So we'll get more streams, but they'll be more specific. This one up here is a pretty big bucket, which says request ID. And then for this one, we have a complicated end of day exists matching criteria, or trigger criteria, I should say. And if you look at a previous screencast, we go into the details of how that works. And in this case, here's the callback for it, and we're going to debug on this one. And debugging has a dumper, so when a dump comes out of some debug information, there are some different output mechanisms you can use for it. One is just some basic stats about what fired and how many went through and whatnot. And the detailed dumper can give you some very specific things about why something didn't match, and we'll go through those in a second. So yeah, let's quickly look at the criteria. So this is where the debugger comes in. So what we're going to look at is some of our criteria. So normally in our criteria, what would happen is, okay, so in every criteria there's a should fire method, and we get a stream, and we see, should we fire on this thing? So in this case, we're looking at the last update, the number of seconds that have elapsed since a last event came in, and we see that if it's greater than a certain amount of time, then we should trigger. And before, that would just return a true or a false. And actually it does as well. But now what we do is we have this debugger object. And the debugger has a bunch of utility functions in it to track why something worked or didn't work. So in this case, check just says this is a Boolean value. If it's true, then add a count to yes, this was successfully fired. And if it doesn't, then not only record that it didn't trigger, but why it didn't trigger. And in this case, we didn't have a timeout, so that's why it didn't trigger. And if you notice, all these other ones now have these debugger calls. So rather than just return true or false, they're wrapped in these debugger statements here. So now we've got a rejected statement. So normally I would just say return false. But in this case, I'm going to say this was rejected. So it's accepted or it's rejected. It was rejected, and here's the reason why. I didn't get a last event. Okay? And in this case here, I'm going to do, again, another check that says, if the last event type is the one that I'm looking for, then return true. Otherwise, I'm going to return false. But in the debugger, I'm going to add a little note to it that says I got the wrong event type. And that way we can do a count and find out how many of these things failed. And if we go down through it, there's a whole lot of different ones here. So the end of day exists is probably our more complicated one. And again, now we're passed in this debugger object. And instead of returning true or false, we're going to return some other hints to say what happened here. So in this case, I've got a criteria mismatch. So this is our firing criteria, and we got a mismatch here that says, oh, okay, we didn't get any events. And that's going to get logged in a certain way. So the debugger, let's quickly look at the debugger object here. The debugger has a couple of things that it tracks. And these relate to all the states along the way. So we got a trait match or a trait mismatch. So that's the beginning stage, right? That's the matching, the distinguishing traits and things. If a new stream was created, that gets tracked. If there's a criteria mismatch or a match, then that gets tracked as well. If there was a reason why the mismatch occurred. and then this is the firing side of it. So this was a check to say true or false, and then when we get into the callbacks, we also have a trigger error or a commit error, but I'll talk about that afterwards. So these are all, the debugger just tracks all these different steps along the way. And this one is just a no-op one. So if you're not debugging a stream, you don't want to have a lot of overhead, whether this one just is basically a pass-through. But when we get into this one down here, we actually keep track. This one is actually called this is the actual trigger debugger that gets created. And this one here does all the counts. So we'll see, how many trait mismatches did we get, or how many trait matches did we get, how many trait mismatches did we get, how many new streams were created, how many criteria matches did we get, what was the reason for this criteria mismatch. So we have trait matches, criteria matches, and then trigger errors that can occur in here. So that's basically how the debugger works under the hood. But all you're ever going to deal with is when you're defining your criteria, you're going to, instead of returning just true or false, you're going to proxy those through the debugger, and that way it automatically happens for you. So you can get criteria mismatches and all the rest of it. So yeah, so these are the sort of hints that we're passing through here. I didn't get an audit beginning or an end event or a trait in there, so I didn't find it. I got the wrong event type. There were no events to look at. The time wasn't 000, so these are for defining end of day things. These are all things that can go wrong when we're trying to match this criteria. And normally I would have to load up this thing with a whole bunch of logging statements and then turn them on, turn it off, and then I'd flood the thing with, how do I know it's this one versus another one, and it doesn't match up, for this particular stream or whatever. This one's a lot more targeted. So let's actually have a look at it and see see how this works. So this is the sandbox. Again, we're gonna run the sandbox here. It's gonna update my virtual environment and run everything in a screen session for me. Okay, so we're on screen 6 here now, and the first thing Notogen ran and just filled this thing up with a whole bunch of events. If I go over to Windows 0, I see one of the Yagi workers going here. Okay, so what just happened here was 399 messages came through on the monitor.info queue, and they got added. So we see that these went into the pipeline system. We've got our two streams. Oh, my voice just cracked. That's interesting. So we've got our two trigger definitions. One is request ID, one is end of day event, or end of day exists. And we see that of these 399 events that came through, they were all added to some request ID stream. And it resulted in 41 new streams being created, actually. So of these 400 events, 41 new streams were created. For the end of day exists stuff, not all of them went to a particular stream. Only 36 new streams were created. So why would these 17 events get dropped? Well, probably they never had some criteria in there that it was looking for. So we were looking for an audit bucket, or we were looking for a instance ID. So if one of those traits weren't there, that wasn't getting picked up. So if we saw that this was a very low number, then we'd go, okay, well, we've got something wrong on our matching criteria. So either we've named the thing wrong, or we gave the trait name incorrectly, or it just didn't get found, and we would know right away something's going on here, because nothing's going into new streams, and we could see what was happening, why that's not going on here. And if we look at Yagi 2, this is another Yagi worker that's going here. And if I scroll back up to when the stuff started coming in, then this on this one here, so the other one got about 400 events, 399 events came in. This one only got 300, but of those 300, they all went into a request ID stream, which resulted in 22 new streams. And this one here, same. Not all of them went into a stream, but this created 30 new streams. So if we add those two up, we see that we processed about 700 events, and it resulted in about 100 new streams total between the two Yagi workers. So let's just hop over now to the next window, which is our expiry check window. Now this is the one that's looking for streams that are ready for processing. So when we first came into here, the first pass through, it didn't find anything that was ready for looking at. So in this one here, remember I said we've got about 100 streams. Actually, we got 130 streams. So it found, it said, okay, I've got 129 streams to work with. 16 of them triggered. So they had firing criteria that matched. And because we turned debug on both, and we're going to get an output for each of these, so we have request ID said none of these matched any firing criteria. So, okay, that's interesting. Why did that not happen? Well, if we remember, request ID triggers on inactivity. So if I didn't see anything happen for the last 60 seconds, then I'm not going to fire. So it knows the streams are there. There's 63 of them that it wants to deal with, but none of them were ready to go yet. So maybe just enough time didn't elapse. But the end of day exists stuff, we did get some. So we've got, out of 66 streams for end of day exists, 16 of them actually matched the firing criteria, and it triggered. The ones that didn't match, so 16 of them did, 66 were available. The 50 that didn't fire because we had the wrong event type coming through, which means it didn't get the end of day.exists record. So that's what we would expect, right? So 16 of them did, 50 of them didn't. The next round comes through, still nothing happens. Next round comes through, nothing happens. The next round comes through, a minute has elapsed now, so all of our request IDs have now just timed out. So in this case, we checked 113 streams, 63 of them were ready, and because we have debug turned on, we can see the breakdown of that. So 63 of 63 available streams match, so all those events are coming through. And then this one here, still, we still have these 50 that don't have anything coming through. Now, I've only generated a finite number of events in this situation, so these will never fire until I put in more events and we eventually get a end of day exists record. In production, typically I would make the firing criteria be a combination of two things. One, that it would be an end of day exists record, and then some sort of timeout as well that says, I didn't hear from this thing in 3 days, so maybe something's wrong, and you can fire it or put it in an error state or something. So instantly from this, we know what's going on. I mean, I can see that everything seems to be processing fine, and I can find out why things are failing. So that's the debugger already has just saved me a whole lot of time. I haven't had to look at any log records or anything. And then when we get into the later stage processing, we can see when stuff goes through and gets processed, and we'll dig into all that in a little bit more detail. But really, at this stage, we're looking at the input, which is at the Yagi stage. This is when events come in and they get sorted into buckets. Why are things failing here? And then into the, well, I call it expired here, but really it's looking for ready streams. But why are streams not getting processed? Why are they just sitting there languishing? What's the matching criteria that's getting triggered or not triggered? And we get some really good breakdown in here. So hopefully that helps a little bit. These tools are available to you as you're starting to craft your own streams and your own pipelines. You can turn on debugging, don't have to worry about looking at the log messages, and you can get in nice human readable form what's happening to your pipelines and what's why things are matching or not matching, and then you can tweak accordingly. So that's quite useful. In a later screencast, I'm going to talk about the pipeline processing in a little detail, and then in a even following screencast, I'm going to talk about the REST API onto this and how you can look at these streams and find out in detail what happened, what went wrong, what went right, and what were the events inside of it. So you can really get into some gory details, and you can do all that through the REST interface. So that's it for now. If you have any questions, as always, just add them to the bottom of the video down here in the comment section, and I'll be sure to respond. Thanks.